of you who are remote and prefer to watch it from the comfort of your living room on a sofa, this session, you're most welcome to do so. Once again, those of you who joined a bit late. Who are remote and prefer, okay, here we go, to watch, this is it. So now we certainly are live. So welcome again, guys. Today, we'll do the following. We'll take a general feedback on the project, to what extent you find the project useful and not. I'll give you guys a preface of how the industry is moving. And the AI industry is moving very, very fast at this particular moment. It is moving both, as always, when things move fast, there's a lot of chaos. Some things are happening. Some things are very, very noisy. People think it means a lot, right? And so we'll talk a little bit about the industry and its strengths. We'll talk about this project, why the project is designed the way it is. We'll take your feedback on whether you feel the project is useful or not. I have a request, guys. If you go to the portal, there is a little survey which is called the first impressions of the project. Almost most of you have not taken that survey. Can I please request you, while I'm waiting for everyone to join, to please take that 2-minute survey. Please go to the course portal and take that survey. It will give me some feedback on how useful you're finding this project and this bootcamp, and we'll steer the projects accordingly based on the feedback we receive. So please take a couple of minutes and do that. Now, I noticed that some people have just come in. I'll let them take coffee. Anybody, now at this particular moment, all of you should have access to a server. As you can see, some of the setup is still going on. And if your team doesn't have access to a good server, let me know. So Andy's Mountain has Patrick's machine, and a Dell server. So guys, the Dell servers are lying empty. They're pretty powerful. Use those Dell servers. Now, some of you have gotten a machine in your room itself. Right? Some of you have kindly brought your own machine for the team, for which I'm really thankful. Sukhpal has volunteered his very powerful server. And Sukhpal's team also has access to a Dell PowerEdge server. So between the two of it, hopefully this team is taken care of. Wasserstein team have their own machine. Andy's Mountain have Patrick's machine. And alchemists have a new machine. Any of the alchemists present here? Oh, there you are. So did you see the new machine there in your room? Yes, it's running. And obviously, Oppenheimers have brought 2 powerful machines of their own. Optimus Prime have their new machine, and Tensor Titans have their new machine. I don't know if you noticed that. It's all there. So now every team has machines at this particular moment. So with that, I'll get started. So guys, once again, can you please do me a favor? You won't get time. You won't remember to do it, but to me, it matters. See, I'm not just an architect or an AI expert. I also, an aspect of me is an educationalist. For me to get that feedback is important because it helps in the curriculum development. It helps improve this bootcamp, and it improves the experience for the subsequent generation of the subsequent cohorts that will come through this place. So please do fill up these surveys whenever you get it. And this survey in particular, please do go and take it. Now, while we are taking it, I want to have a general sense. Obviously, these questions are asked in the survey, but I would like to have a, by the way, your responses are anonymous. I don't get to see who said what. Right? And nor do I want to see. Even if I could see, I don't want to see. What matters are the statistical numbers. Is that 9? Okay. So now, how many of you are completely done, fully in production? You're done and fully in production. Wow, amazing. So then you guys would like to do a demo? Really, you're done? Yeah. We didn't see it. Okay. So if you're fully done, so we'll do that. Now, guys, here is how we are going to do this. I'll wait for the ringtone to go and then we'll talk. Yeah. So we will do it like this, guys. Just a general poll for most team. I felt that people are in different stages of progress. Amrit, is that true?
You could say that, yeah.
So most people have done the POC level, like they have all the pieces in place. Is there any team? So let's go one by one. Is there any team that has not completed just plain text extraction, a proof of concept? Have we all done that? Yes. Has every team done chunking? Every team has done chunking. Very good. And you may have all sorts of ways of chunking, fixed length chunking, chunking on paragraph breaks, chunking a bit more clever than that, right? But some form of chunking you all have. Have all of you, has every team been able to, just as a proof of concept, not production level, being able to use the sentence encoder to create embedding vectors, right? This is straight from our NLP with transformers. Jupyter Notebook, for example, had that code, right? Did any team deviate significantly from that, like use something wildly different? Not use a sentence encoder at all. Okay, very good. Now, have you guys all been able to use some form of approximate nearest neighbor algorithm to create index? Has every team, at least proof of concept, been able to do indexing? Right, good. And once again, that is there in the NLP Transformers Jupyter Notebook, right? Now, how many of you used FAS? How many of you did not use FAS or use something else? No one. All of you use FAS. Okay, so we'll go with FAS. And after the indexing, how many of you successfully, many of you did the cross encoder? Which team? Only alchemists have done it?
We also did it, but we have to test.
You have done it, huh?
Yeah, end-to-end in production.
End-to-end in production. Albert, you don't even know what your team has done.
I have to display, I know the UI. Maybe he has hooked it up.
All right, so this is good. Cross encoder. Now, when it comes to cross encoder, remember, guys, what a few ground rules. If you're using a cloud service, like if you're using Google or Cohere or Anthropic or any one of those services to re-rank, it's an automatic disqualification. Right? So that doesn't count. You have to use your own cross encoder and you have to explain. So next week we'll have presentations. You will have to explain with good theoretical reason why you chose that. You can't just say, hey, I found it on the internet, I chose it. Right? You have to give a justification for that particular cross encoder. Right? Now, do you guys know why we need a cross encoder at all? Who would like to give me a 1 minute reason? Why did we do a two-phase approach? First the embedding and then the cross encoder.
Compare two sentences.
Now, why would we do that? 1 second. Yeah, go ahead, Mosmi.
Embedding is faster, crossover entropy is more expensive. So you want to do the heavy lifting with a faster thing and then re-rank it to get the optimal.
Excellent, Mosmi. Go ahead, Athira, your answer.
So, from what I've understood, cross encoder is a very fast. It takes a lot of time for the computation, but it's very accurate in giving the result for the similarity. And it compares the user query with we're taking the result from the Elasticsearch and the result from FAIR.
Excellent.
And we are making
Excellent.
a union of that and then comparing it with the user query using a cross encoder.
Yes. Very good, very good. And this is very good. So those of you who are remote, the answers given are that first of all, embedding vectors, comparing embedding vectors, cosine distance, it's a dot product, it's matrix multiplication, it's vector multiplication, it's extremely fast, right? And so those comparisons are cheap. Then complete using a transformer, a BERT architecture, encoder architecture, and then feeding in two segments, two sentences, and looking for the matching between the two sentences, degree of match is expensive. Remember, it has to go through the full transformer, whereas the dot product you could do on a CPU, isn't it? That's an expensive operation. So you want to do it on a smaller data set. You want to use the embedding vectors to do a quick search of the candidates, right? And the candidates may not be in perfect order. And then you want to use a more accurate a full transformer to re-rank it. Are we getting it? The second aspect is that there are situations in which a semantic embedding is not as good, especially when there is not enough semantics in the document or the query. If I just say apple, do we mean the fruit? Do we mean the laptop? If I say bank, is it the river bank? Is it the financial bank? Or is it your aeroplane banking? Right? You don't know. So it turns out, and this is the trade-off between so-called sparse encoding or sparse embedding and dense embedding. So when you look from an embedding perspective, the keyword search, and when you try to match, they use something called, like I told you about the inverted index. And when you do the comparison, because you may not get exact matches of keywords and so forth. So what you do is you use something called TF-IDF. TF-IDF is something you all know. We have been through the NLP course. Term frequency, inverse document frequency. Right? It's a very old way. It has existed in natural language processing since literally prehistoric times. So, and it works. When you don't have semantics in the data, it works very well. Is the best you can do. And so what you want to do is you want to get some results from here, some results from here, because you have the confidence that you can re-rank all of them. Isn't it? You can re-rank using a transformer. Now I'll ask this question, because now you guys have experience. Tell me, why in the world did we use FAS? Or why did we index with FAS? What is FAS?
Faster computation.
Come again?
Faster computation. Basically, it finds the
Faster. But what does it do? What does FAS do? Srinath.
Similarity essentially works if you have just
FAS doesn't do that. FAS
But
doesn't do
FAS
that.
helps if you have millions of data that
Yes.
you want to search on. It provides an algorithm that you can use to effectively or efficiently search on a huge amount of embedding.
Very good. Amrit.
it's just approximate nearest neighbors.
Approximate nearest neighbors. So what is approximate nearest neighbors? Annie. Go ahead.
Instead of KNN, which is looking at every
Exactly,
other point
yes,
in
yes.
space.
So what is wrong with KNN? I thought you were finding your neighbors is a good thing.
It is, but you're looking at every other point in the space, which is very expensive. So it creates cells instead, and you're looking at only within that cell for
That's
points.
Yes, very good. Anyone else would like to articulate? What's the difference between exact nearest neighbors, that is the KNN, if I want to have 10 exact nearest neighbors versus 10 approximate nearest neighbors? What's the fundamental difference, and why in the world would I want to lose optics? Why would I want to get only approximate nearest neighbors and get a few things wrong? Anybody else? Go ahead, Kate.
Because it's much better to be able to scale up to huge demands.
Absolutely. Kate said it's much better because it will be able to scale up. See, what happens, guys, think of it this way. Suppose you have 1 billion pictures, and billion, by the way, is a small number. These days, if you look at the places that use these algorithms, you guys, for example, are building. I told you that this bootcamp is not for POC. If you want to do POC, create a POC, write a Medium article. Right? We are here to create one. We are here to create things at scale, true industrial scale, right? Web scale. So to do that, you have to assume a number that is orders of magnitude higher than 1 billion. Are we together? Orders of magnitude higher than 1 billion. Now think 100 billion at scale. Now, even with the hardware that I've given you, 1 billion is the minimum you should be thinking of, right? When you are doing, you take a vector, query vector, and you compare it to find the nearest neighbor. Even if you have 1 billion points, you would have to do 1 billion cosine similarities or whatever distance similarity measure you use, dot similarity, Euclidean similarity, whatever it is that you use. However fast your matrix multiplication is, a billion is a billion is a billion, right? It's a lot. And the bigger your data becomes, the more successful you are, the slower your site becomes, isn't it? You cannot have that. Now, for many, this problem is not just true for search or something. It has been an old problem in computer science, and people have come up with various data structures. They have come up with so-called metric spaces or embedding spaces or things to decompose the data space into buckets, into cells, like Amrit used the word cells, some sort of cells, a coarse-grained resolution. So one way that I could illustrate this thing to you is that, see, if you look at a beautiful painting these days on a monitor, it is what? Each is 32 million colors. Each pixel could be anything in the 32 million colors, isn't it? But if I reduce it down just to 8-bit colors, right? 256 colors, RGB, you realize that the color space has been reduced. So many shades of a color, many shades of green will map to the same bucket. But you would agree that if you get a green query, it makes sense to only search in that bucket, right? And ignore all other, that particular shade of green bucket, right? So suppose you have 32 million shades of green, but you made only 256 buckets, right? What are you saying? You take a query vector and you see which shade of green is it amongst the 256 and go into that bucket and only there look for neighbors, right? So you have significantly reduced the size of the problem you are solving. That's one way of doing it. The other way of doing, I mean, there are techniques. So this is a geometric approach to sort of bucketizing or reducing the size of the problem. Other way you could do it is quite literally numerical quantization. You can chop off, like if something is, for example, one easy thing people do, and obviously we covered the paper Q-LoRa. What do you have? You have a number with too many decimal points, right? You chop off some of them, round them to just 16-bit. If you have a smaller GPU, like if you have 4 GPUs, 16-bit. If you have 2 GPUs, maybe 8-bit. If you have 1 GPU, 4-bit. If you have no GPU, then maybe 1-bit. So that's quantization. Right? So there are techniques. There are all sorts of techniques, locality sensitive hashing, metric spaces, this sort of quantization that have existed. All of them try to reduce the size of the problem at runtime, right? Then you have to just somehow get to a smaller neighborhood quickly and search. Right? It's somewhat like saying, I'm looking for money and I don't know where in the world he is, versus saying, I'm looking for money and he happens to be at support vectors. Much easier to search for money now, isn't it? You zoom into support vectors and it's just one amongst 35, 40 people here. That's the difference. So that is the value of approximate nearest neighbor search. Computationally, it reduces something that would take your lifetime to solve down to milliseconds or microseconds sometimes. That's why you use. Now, when you do that, ANN algorithms have been evolving over time to such an extent that there is literally an ANN benchmark, a website called the ANN benchmark, where you can see which ANN algorithm is the leaderboard. Now, as of this moment, I believe it is a combination of FAST and HSNSW, right? That is there. And these are, each algorithm, if you look at it, they take very different approaches. For example, FAST has one approach. SCAN uses sort of anisotropic properties of the data. Then HNSW, hierarchical navigable small worlds map, uses a graph theoretic approach to data. The small worlds thing. By the way, when you hear the word hierarchical navigable small worlds map, quite a mouthful, right? That reminds me of Mary Poppins' statement. What is that? Supercalifragilisticexpialidocious. Like she teaches that kids, if you ever want to gain confidence in front of grown-ups, use this word. So hierarchical navigable small world snap sounds somewhat like that. You can bomb it on your unsuspecting boss. Right. So what does it mean though? Can somebody tell me what does it mean? Where does it relate to? I'll tell you where it relates to, just to give you an intuition, because we are doing this, so it may be a good idea. Obviously, I am not doing, when we do graph neural network, by the way, it's a separate workshop. Graph neural networks are becoming very, very central. Then I'll cover these things in detail because I cover network theory. One of the great discoveries that happened around the turn of the century, and it was actually made by a theoretical physicist, I believe, Bayabasi, was that networks show a sort of scale invariance or scaling law that is very common in physics. Right? See, it's a fractal-like structure. You notice that fractals, you zoom in, you see the same structure. You zoom in, approximately the same structure. Right? The snowflakes will show that behavior. So what they found is, if you take a complex network, sufficiently complex network, what you start seeing is, you start seeing communities of nodes together. Think of clusters, right? Interconnected nodes. And then within the community, you find sub-communities. So the whole network is divided into these small worlds. Are we together? And they're navigated because they're interconnected and so on and so forth. Right? And so think about it. Does that immediately lend itself to an approximate nearest neighbor search? Why? Because you take a query vector, go to the community, go to the small world it belongs to, search for neighbors there. Do you see how intuitive it is? Right? So guys, all of these algorithms, they're deep, they're elegant, they're beautiful. And when you think about it, there are very simple, good ideas behind it, good insight behind it. It's worth knowing, right? So I encourage you, if you have time, to also try HNSWLM as an enhancement to your project, or hybridize the two and so on and so forth. See the differential benefits of that. So guys, that is in pieces, all of you have done that. How many of you did a microservice? And did all the teams do the microservice? All of it did that. Mosmi, you were waiting to ask something.
Oh, no. I said that I did the microservice.
Oh, you did the microservice. Good. Microservice is done. And how many of you have done some level of some primitive UI? Right? Which team has not done it? Is there any team that hasn't done a UI at all? Tensor Titans look tense.
Very dense.
The UI is not there, huh?
It's basic.
Basic, yeah. Well, get it done. I sort of gave a very softball. It reminds me that somebody said Van Gogh painting, right? And somebody makes a stick figure and sells it and says, this is very early Van Gogh. So maybe you have a very early UI.
All we need is a text input boxes. That's the
so guys, now all of you have the key ideas. And now I want to pause you and give you why I gave you this project. See guys, the AI community today is fractured. It has a problem. It's a tribal nature of things. There are data scientists who are very good with the linear algebra and math, right? They are the mathy ones. Then there are data scientists who are super good with the Python coding. The moment something new comes on Hugging Face or PyTorch makes one more module of Hugging Face as an extension, they're all over it and they're playing with that API, right? That's another kind of data scientist. And then all of these are necessary. They do a great job. The first are more academic, mathematical people. The latter are more hack-based. What is the issue is that when you solve a real-world problem rests upon, you realize that you're building all of this and trying to use it in a system, especially if you're doing web scale or enterprise scale. You are trying to solve a problem which needs other skills. No, those other skills are not hard. It's just that you may not have it. Somebody else has it. You need to know data engineering. You need to know pipelines, data pipelines, MLOps or DevOps, right? But more than that, more than anything else, you need one thing that is most missing at this moment. a really deep understanding of how to craft an AI architecture. See, everywhere you find, if you want traditional software architecture, Martin Fowler has written excellent books on it. Patterns of enterprise software architecture, right? Then OSA volumes, pattern-oriented software architecture. So many books on architecture are there. There is domain-driven design. There is this, there is that. You know that, right? Architecture books are replete. The traditional architecture has matured very much. Unfortunately, the people who understand how to create large-scale systems, AI systems, are missing. Genuinely look around. Right? Today, I keep quoting the saying of Tolstoy that all happy families are alike. Each unhappy family is unhappy in its own unique way. You go to almost every AI shop, every AI startup, every AI enterprise, or different AI teams within a large enterprise, you will realize that they all have some things right. In fact, everything that you did, in pieces, they get all the pieces right. And yet, the sum of all pieces is wrong. It doesn't work. Is that an experience anyone resonates with? You see it fairly universally, or it is a suboptimal thing. Architecture is not something you can ignore, guys, because if you are not conversant with architecture, you will not only build a product, you'll build a mountain of technical debt along with it. And soon the technical debt will drown you, will slow down your project. This is the history of, this is really the history of software engineering. Most projects fail. AI projects particularly fail, right, these days. And if you ask why it failed, you never can tell the reason, because each of the pieces will work, right? It is in the sum total of that you have. So this boot camp was all about creating good architectures. Sorry, I think I lost my, I need some batteries. I'll take care of it later. So, oh, there's give me a
So,
moment.
sir,
Yeah, go ahead.
so that's one of the reasons why people are looking to consolidate companies. So I think you're aware that a lot of that is going on. And even at work, we have workshops regarding architecture, how all the pieces fit. And while some people don't have UI abilities or some other abilities, we're kind of being put to task and being put through, I wouldn't call it a screening session, but kind of an exam almost, to get better at that. So
Yeah.
I resonate with what you're saying. It's kind of we're at a conjecture in the field where this is being looked at. Yeah.
Yes. So guys, thank you for saying that, Shalini. So at this particular moment, guys, this course, this boot camp is all about making you that rare breed of people, AI architects, right? A person who's both a data scientist. See, guys, if you have been through support vectors training, you're not just a hacker. You're also mathematically trained. Would you agree with that? How many of you would agree with that? Right? We didn't spare the math. We did the math. You are a full data scientist. Your background, most of you come from software engineering background. So you have some experience with data engineering. But when I look at all of you, not many of you, very few people get to make large-scale architectures, because in a company you can have only so many architects. So you don't get that experience. And when it comes to AI architecture, you simply don't get it. That's what we are going to get here, end-to-end experience, from math to deployment. Right? That's what it is about. Yeah, go ahead.
I had you were referring to ANNs earlier, right? What is Pinecone use? They don't use space, right? A form of HSW?
Yeah. So most of the people who have gone live, see, one of the things you'll realize is, and this is the emerging power of graph neural networks and graph structures. Hierarchy, HNSW hybridized with FAS. They are using hybridization of these two, from what we know. Right? And I would suggest, if you go to the ANN benchmarks, guys, you will see that is at the top of the leaderboard. FAS plus HNSW, a hybridization of the two is at the top of the leaderboard. Right? And so I wanted to hear that somebody has tried out a hybridization of the two. Right?
Where do you see that, Ashok?
Come again?
Where do you see that?
Let's see. It is. Let me bring up the browser. Let's find it together. It's called the ANN benchmark.
No, I'm on the website, but I don't see.
Let's find out. Let's find out. Yes. So are we all looking? By the way, am I sharing my screen at all?
No.
I am not, obviously. Truly, I'm going senile.
Sorry, recording.
Yes, we are recording. Sorry. So let's go to ANN benchmarks. So
Also,
let's look
do you
at it.
believe, sorry, do you believe this is what top companies are using? Because this is not something that I've been hearing recently. So just to put it out.
No, say that again, Shalini. That was something interesting. You said.
Yeah, so you said it's FAS plus HNSW that we'll be using, but other companies have moved on to different algorithms and different techniques as created by the math people. So I'm just wondering, is this open and the other is closed? I guess because I haven't heard about this at work, so or people are using other techniques. So I just kind of, it was just a question.
Shalini, I don't know. Like, for example, let's take a company like Cohere or Anthropic or OpenAI or any of these people who give you, for example, some of these embedding and search as a retrieval as a service. What they are using, they haven't publicly said. But in my opinion, you can always find out what they're using by looking at what research papers their researchers are publishing. Right? So I haven't seen any completely radically different algorithm come out. So when you look at this leaderboard, do you notice that, at least to me, it seems that what we are seeing here is HNS, like, look at this light green one at the top. It is, these are all papers. These are all well-established things. And the queries per second and the recall, if you look at the recall, this light green is doing very well. Scan is doing very well. You notice that? Then HNSW, right, is doing very well. There are other algorithms like NGT, QG, and so forth. So these are all sort of leading algorithms. Some of these I don't even know. Right? There's PG vector, I know, tiny KNN, of course, ball tree. Ball tree goes to the same family as KD trees. These are all metric trees, metric tree based algorithm. So FAS IVF is not doing badly. Actually, it's also doing pretty good in this map. You see that it contains quite a few variations of FAS here. So I don't know. I can't comment on that, Shalini, because I wouldn't know.
No, we are also looking into as IVF.
You are?
Yeah, because HNSW is requires a large memory.
Yes.
That's the pro issue. But you get the same quality with IVF with less.
Okay, so here Praveen is sharing his experience, which is very useful. That HNSW uses a lot of memory, gives you better results, but FAS with IVF gives you almost the same results, with far less memory. Right? So that is a valuable experience from you guys. So play with this. Right.
Asif sir, I feel like with this boot camp, there has been a lot of people have a lot of results, even in just my own team, the Tensor Titans, people get a lot of good results. And Mouseme just asked about Pinecone because that's a discussion we had last week. And, you know, Pinecone is kind of getting up there in terms of vector databases, and they have made several claims. So I think with their LLMs, before it's too late, how do we create documentation? Because a lot of people, even just on my team, have done a lot of good work. And how do we just document this in a way that is more organized? I mean, I know we're talking about indexing, but how do we organize all of this so that this can be something that is creative? This could be a book.
Yes, guys. So that brings me to the, thank you for bringing it up. That's exactly what we're going to do. Just park your question for a couple of minutes, because what I'm going to say goes to the heart of answering you there. So guys, we have all done the pieces. We agree with that, isn't it? Now comes the piece, how do we put it together? So I can tell you what, I won't tell you. So, okay, well, let me put it this way. Let's set the ground rules. We are going to judge the projects this way. First of all, none of you guys are done, really done, except for Ranade, who says, and we'll see, we'll take his demo. If he's done, he has gotten ahead of you.
Yes.
No, oh, that disqualifies. Have you used Anthropic?
So basically, the data science part.
Go ahead.
So the data science part.
And the other guy.
Guys, just get out of the audio part of your laptops, because if you are connected to the Zoom with audio, it won't come through. Go ahead.
Yeah, what I was saying, the data science part, Abdullah and Dennis, they both cracked it. I have no clue what is going on inside their script.
Where is Abdullah? Where's Dennis?
He's coming in afternoon.
So you guys don't know what he has done. But if you have used Anthropic, that disqualifies you.
I mean, we can read the script, we can understand the script.
Okay, guys. So I'm going to lay out some ground rules of how we are going to do it. You guys all get 1 more week to finish it. All right, this project. Now, this project, we are going to do a leaderboard, right? There are 12 leaderboards. Each project will be judged, and I'll write it down so you have the notes. Let me write all of these notes for you. Guys, by the way, if you're seeing my screen, do you realize what a far cry this bootcamp is compared to the last meeting we had, reading these research papers, isn't it? So, guys, I'm setting the rules, please pay attention. First of all, there will be 12 projects. Each project has 2 parts. 1 second. Each.
We can't hear you properly on the back
Oh
side.
yeah, I think I lost mine. In the break, I'll look for batteries. Right? I've run out of these batteries. Sorry. So I'll try to speak louder. See, guys, here is how we are going to organize this. This is the entire thing is gamified. That's how it's going to go. You will have 24 projects. 24. Oh, sorry, let me make it bigger. Why am I not editing? Sorry. That's all. 24 projects. 12 of those projects will be no-brainers. First week, how many projects did I give you? 2. First was do ChromaDB. I trust you guys have done that, because I'll expect every team to show me at least 1 notebook on playing with ChromaDB. So guys, that is a softball. There is no way you can get that wrong.
Can you repeat it?
So first week, guys, pay attention here. Week 1, there were 2 projects. One was play with ChromaDB. Remember, the instructions said that. It's on your course portal. Right? The second was the real project. Right? Build a search engine. Now, every week, or in the 12 projects, you will always have an easy project, which is just for learning. And that is the floor, guys. If you're not even doing that, and I can already see many of you haven't even seen the instructions. right? It reminds me of a cartoon. There is this very lovely joke or a graphic. Institute says the Institute for the Mentally Gifted. And there is a guy on the door, it says pull, and the guy is pushing at the door with all his might. So you guys are all brilliant people who are doing a very complicated search engine, and you forgot to read the basic instruction on the course portal. Right. So you need to do that. So this is an easy one, guys, and I will. Next week, you'll have to convince us. Every team will have to show evidence that you have done that project, right? So that will be the softball one. Then will be the real one. Softball is meant for something. It gives you a reference of what is it that you are building, isn't it? And it gives you a way for you to compare your search results against this product. It's a product. That product has maybe hundreds of engineers or dozens of engineers working over months. You guys are a team of 4 or 5 people trying to do it in a week. If you can come within shooting distance of a real product, isn't that a matter of pride? You may not beat it, but if you come within approximately, you're able to do the same thing. Isn't that a matter of pride? And you understood how these things are built. So that is why you are given a reference softball project every week. Are we clear? Now this week, because it was a starter week and part of it is on me, I had time to get the infrastructure in place, the machines in place. I still have to get the PF Sense. So Pal, we'll do this PF Sense today. Yes. Yeah, the network access and so forth. So we are going to have an extra week here. And with that extra week, you'll finish it. But what will we do next week? What will we do today? I will poke holes in what you have done. Now I claim, do you see these magicians? You tie bandages around their head, black, put a monkey cap on their head and put all sorts of things. And yet they're able to walk around and see people and avoid traffic. Okay. So somewhat like that magician, without actually seeing your code base, I'll try to guess and navigate to all the mistakes you have made. But you have to confess to it honestly. Right? What is the purpose of that? See, we learn from mistakes. We are human beings as a species, we are bozo sapiens. Right? So I will point out all the mistakes that I'm sure you have made. And then you'll learn from that and you'll do better. So next week, when you come back with a solution, you will come back with something better. Make sense? By the way, when I say these are mistakes, remember one thing, the bar is very high here. What we call mistake, most people in companies call a product ready to release. Seriously, right? So remember that. So don't get discouraged by that. The bar is high here. Now, next week, you will have a leaderboard. So each week we'll do this. You will present your project, right? Saturdays, you will present your project, guys. On your project, there will be 5 metrics. Each metric, everybody has to judge and vote. So participation matters, guys. Your scores, if you so choose, you can keep it confidential or you can tell. It's up to you. But for each team, you will have to score on a scale of 1 to 5 on the following topics. Completeness. You'll have to give a score on the completeness score. You have to give a score on the AI metrics, model metrics. How well is it doing its job actually? For example, how well is it able to search? Right? Scalability, performance or latency, and in participation, how evenly contributing were each member of the team in your perception of that team. Like, did one person do the whole project? In which case they get 1 out of 5. Right? If all of them contributed something, because great things are done, like you say, right? You know the old saying, great things are done when men and mountains meet. Right? You can't move a mountain alone. You need a team to do that. So,
We forgot UI.
okay, we'll add UI also, the beauty, the aesthetics,
Usability.
UI usability,
User experience.
and team cohesion, team spirit, teamwork.
Also, are you covering concurrency with?
Yeah, so that is a consequence of concurrency would be scalability and performance. So we are not explicitly. So guys, you notice that there are 6 metrics. I had 5 in mind, but we added 1 more. Very good. 6, right? Now what will happen is each team will get scores. The cumulative scores at the end of the boot camp makes the winner. Each week there will be a winner. The winners will be posted. All the team scores will be posted. Whatever you can't score yourself. Right, so other people will score you, and those scores will be published.
So can you go a little bit into scalability versus performance? It's a very interesting topic.
Yes, so performance is about how quickly you can respond to a small number of queries, right? Per query response time, average response time. So suppose the number is just 100 per minute. What's your average response time for different length of queries? On the other hand, scalability is I keep on increasing the number of queries. And at what point does your latency become unacceptable? Or you start throwing out of memory errors.
So performance at a low scale doesn't even mean anything. It must be a scalable system for you to actually test performance.
Yeah, see, I'll give you an example of scalability without performance, right? I can take infinite number of queries. For each queries, I will take a week to answer it. Right? So you have infinite total scalability, but no performance. Right? Performance is more closer to latency, and scalability is that, and they are opposite forces. To get one, you have to often trade off on the other. Because to bring about scalability, you invariably have to have a more complicated architecture. You need to have queues and things like that, and that does affect your performance in the small.
Yeah.
Right? So it's a trade-off.
So we don't have a scalable system like on some cases I got a 6 segmentation fault or memory error.
On which machine?
On I have 40 GB RAM and
40 GB RAM. But we have given you.
But we don't have a GPUs. Do we have GPUs?
Yes, of course. We have a big 4 GPU. Like we have literally 100 GB VRAM machine, right? With what is it, 512 or 1 terabyte? Some massive amounts of 512 GB RAM.
The language selection also varies. Like if the team selects Python versus Java.
That is your internal matter. All we will judge is at the end of it, it's a product. Business doesn't care which language is your favorite, right? Or which particular, whether you choose Spring Boot or Quarkus or Flask or Fast API or whatever it is. Those are internal details. At the end of it, from an end user business perspective, all that matters are scalability and performance, AI model metrics, and whether it's feature complete, isn't it? And that's what you say. Remember, guys, I'm putting you in a product development mode. Sanjay. Each one of you have to give a subjective measure. Is the wisdom of crowds. Yes, yes, of course you'll have a benchmark.
So you will have some test scripts that you will put on the machine and test that.
Yes, and I will give you the test script this week. You'll have to do that.
Yeah, okay.
But I'll give it to you at the last moment so that you don't give a bill to it.
Yeah.
Go ahead.
So when are you going to test this?
What's that?
Like, I mean, are we going to
On the
test
inference
like-
server.
So basically then there's also deployability, right?
There's a deployability.
You've got it working on your machine. you just
It's
have
not
to put
enough.
it there.
It's not enough. But here's one experience I'll tell you one second. That for this problem, because we are using, see, we are not using any very large language, right? We are using basically is bird family. A bird family runs just fine on a 4090, amazingly well. So if your answer is not, if it is scalable, it will already prove scalable on your box, right? So you really don't need that inference server. You'll need it for the next project because there you have to fine tune.
One other measure which is not there is
Yeah. So yeah, those things. Yeah, let's keep it. It's a good one, and security and so on and so forth. But yes, We won't keep it to that. So guys, are we clear on how this project will work?
So
Shivani?
one more thing that would be good at some point is role-based access or some kind of security part of that part.
Security is going to the enterprise, what we have access. Some people have access to only some data.
Yeah.
See, it's a very good topic, but it gets very enterprisey and a little bit away from the core. But however, so there are two projects, guys, at the end. The 11th and the 12th project is in the nature of bring your own project. Each team gets to bring their own project. And I will guide you in that based on what startup you want to do and so forth. So Shivani, in your case, this matters. The other is the tabular data inside. Both of these matter. So that looks like your 11th and 12th project, and I'll guide you through it. Kazi.
Yeah, so basically we said we'll have 24 projects, but each time we'll have like a soft project and then
A real project, yeah.
So basically it's kind of a like combined, but basically we have 12 hard projects.
12 hard projects.
And then the last two ones are, we can do our own.
Yeah, last two of those.
So for all projects, it would be good if you like you have a testing matrix. Would it be good that you also give the kind of like here the search engine, we took some sort of some document on the web, and that some document may contains a lot of data, and Tika servers or other things go down.
No. When I look at scalability, I will.
If you can also give us an input, then we are all on the same page.
Yeah, so I'll give you a basic input. 10,000 documents, right? Basically, I'll give it to you a very soft metric. If you're not able to process 10,000 documents in an hour, it's a disaster.
And which 10,000 documents? That's
okay. So let's, for example, take 10,000 Wikipedia articles.
So then, if all team use that same Wikipedia articles, then it will be. There will be a good comparison.
Yeah. So I will give the benchmark, and I won't show the benchmark. I haven't shown you the corpus of documents. But if you want to improve your algorithm, see, guys, here's the thing. While development, take anything. Take, for example, I'm saying if you take Wikipedia articles, they're very short. A typical Wikipedia article is what? On a median length is about 6 paragraphs, 6 to 8 paragraphs. Couple of KBs, right? If you cannot process 10K of them within an hour, you're a disaster. You should be able to process, ideally, 10K of them per minute. Right? A minute.
So I think from that perspective, we should standardize the input. Because, for example, when we were doing the downloader, a conversation that we had within our team is, do we need a crawler? Do we need a list of URLs which we just going to download? Are we going to get the files? What exactly are we going to do? And we went back and forth and we wrote a partial crawler, partial downloader. So at least from your test framework, you may not give us the data file, but you should say, I'll point you to a list.
Yes.
And you will need to do all of it.
Okay, excellent. So that brings up a very good point, and I missed the most important metric, guys. See, to the reason, so I'll answer your question, Satya, exactly. See, first of all, that question is valid. So I'll give you a standardized test data. Right? So all of you can try with that. See, you can, and I will tell you, if you're processing that in an hour, it's a disaster. If you're processing that in 10 minutes, you suck. If you're processing any faster than that, it's getting better and better. If you're processing it in under a minute, you're wrong. Right? And obviously, on this machine, if you're processing it in 10 minutes, quite likely on the main inference server, you'll process it in a minute. Right? So put a multiplying factor, the multiplying factor of at least 4. Like you'll be 4 times faster on the real machine. So no, hang on. So, but I wanted to mention one important is the domain usefulness. See, guys, the reason I didn't give you a data set is I want you to build a product. I want this effort that you're putting in. See, you guys are all high value engineers making what? $200 to $400 an hour. You're giving on a Saturday, beautiful California Saturday. You guys are coming here and giving your high value time. The end result should be something really useful, which is why I gave it open to you to pick a domain, pick a data set, such that at the end of it, you guys can take it live and release it as a product on the web. Right? So one of you were talking about 10K filings, for example. Check out our website, Sec Insights. you will notice they don't do anything. They don't, in my opinion, they're nowhere as good as what we have done, what you guys are building. And yet, why are you guys not doing it? Right? They went to market. They see business runs on value. If something is even marginally of value to people, that's already a business. You realize that, right? That's already a startup. And you need to get into that mentality. Pick a domain, pick a set of document such that the service you give is of some value to some segment of people. So that brings me to the last point, domain usefulness. We will have domain usefulness. Kazi, somebody's hand was raised. Yes.
Yeah, no, I think maybe this, because I just came today. So I think maybe the spirit we are trying to bring in the team is obviously we want to compete and everything, but we can compete on almost like some stupid things and not really learn out of it, right? So you could, so if you go point to Wikipedia like someone once, I think what the spirit we are trying to bring, at least I understand, is like, let's really try to learn the subject.
Yes.
And apply it to something which is useful for us.
Absolutely.
And so as a team, if you feel like this is the area that's useful, then let's go for it. Right?
Absolutely.
And then as we are doing that, it'll be great to compete as well. But
exactly.
it's not like to win the competition, it's just like
yes,
learn.
Exactly. As a leader, you realize that if you become a valedictorian or you get what is it, summa cum laude or something at Harvard, they don't give you anything except a key. You know that, right? They give you a key apparently. And that key is supposed to be the secret to knowledge or learning or life or whatever it is. Supposed to symbolically, they give you a key. So look forward to winning a key or something. I don't know what it will be, but something like that. But the point is to do our best and build something useful, guys. Huh? So are we clear on the rules? Okay, so now I'll go to the next phase. Today, guys, continue to Praveen.
So when you say processing, right? If I assume it's a processing and indexing, so it's a bad job. So it's all
Yeah. So both for the producer and the consumer, there'll be one benchmark of scalability on how fast you can process.
And the next one is the
actual runtime inference, inference performance. Both of them, inference performance and inference scalability. Right. So there are two aspects, guys. Very good, Praveen. Thank you for asking that. We will test for all of these metrics, both on the producer and the consumer side. Right. And more broadly, both of the training, I mean, when you later on, when we have models to fine tune, etc. Anyway, we'll talk about this. So these will remain your metric, guys. As we move forward throughout the workshop, these 1, 2, 3. Now we have ended up with 7 metrics, it seems. 7 metrics, 5. So ideally, every week you can earn 35 points. Each team can earn 35 points. If they get 5-star on each of the metrics. Right? Okay, go ahead.
Slightly tangential question though. I'll pose it and we can take it offline as well. I don't want to disturb the class. Anthropic and other allow you to upload PDF files. I can upload 5 PDF files and it allows me to do a search on it. Right. How different is this from that?
Nothing. You can do exactly the same.
Exactly. Then why use of the papers? Startup which is filling the data as opposed to using the Stanford or Google, but let's say I am just do the same thing.
See, mostly, so the question I'll reformulate is, today you can upload to Anthropic, to Cohere, to OpenAI, to Chat PDF, and all of these websites are PDF, and you can talk to it. So what value does our project bring? Who would like to answer that? Go ahead.
I think first is efficiency. Cost-wise, it's a very efficient project compared to, like we've done PDF for all, that model that is there where we can talk to a PDF. We've already deployed it, but it doesn't get us there. We're doing it on Azure.
Yeah.
And it's a very expensive proposition in terms of how much the cognitive search feature costs overall. So from a cost efficiency, if somebody could stand up this kind of an infrastructure and then support it, it's huge value to the enterprise for small, medium companies.
Small,
Very good. Go ahead.
For us, like in those, because we would not have like anyone doing this custom app and like, there is a allergy in terms of the custom application. Yes. I think for me, the way I'm looking at it is in 2 ways. So one is we do products that we do market as a company. So we have SaaS product that we pursue something that can apply there. internally, I would say, as I'm like, looking at 2 or 3 different vendors or 4 or 5, I could make a comparison, like at least an idea of like what they are doing. Right? And so if I get a price point, let's say like 5 million, 10 million for a search engine, I can say like, is it like really worth it? Can I pay for it? So it gives me like a lot more understanding. Plus, when we look at this whole AI-based applications, to me, this is like one component of it, and hopefully the other colleagues will figure something else. So in the future, like, I know holistically how you transform enterprise from an AI perspective.
Yeah, and I got one more thing, Moshe, that I'd like to add, especially in compliant industries like ours. What happens is that when we buy from these vendors, the black box that we get, security is one issue we're gonna run into. Second thing is, we don't buy black boxes. We are used to knowing what the vendor provides. Either you give an audit report that supports that thing, and you tell us what the components do, and then we rely on that and we accept the risk, or we should know it by ourselves. So that is a huge challenge why, at least in life sciences, AI adoption is so low overall, because we can't make sense out of the black box.
I come from a similar industry. I come from the security industry, and compliance is such a big industry. So, but
So guys, it's a very interesting topic. Let's discuss it after this. So guys, here's the thing. The value first is you are doing it. When you do it,
the learning step,
the learning
time, and understanding those things in a week time, doing a search engine is really a great.
Exactly. Don't you guys get a high that what million dollar, this $200 million funded companies are doing? You come within the ballpark of that, starting from scratch and not knowing this industry at all in a week. Secondly, any super secret document, like your own plans on how to be successful at nuclear fusion, cold nuclear fusion, perhaps, you get to keep to yourself.
Yeah, no, I was not questioning the value of this course. There is a cumulative experience here that we can gain.
Yeah, that is the value, exactly. Mostly, as you said.
And also LLMs, mostly LLMs hallucinate. There's a lot of engineers in these companies that basically look at the responses they give, and they even make up random dependencies. Like I was looking at something for physical science, and it created something called Mujcoco, MJCOCO, and I spent like 3 hours looking all through GitHub to figure out if this is something that actually exists, because I never heard of it. And then we have to classify that as a hallucination. So it does create some things, because it looks at the things that are statistically closest to it. So I mean, in some ways, if there were high advanced aliens and they came down to Earth and they looked at our LLMs, they'll probably die from laughter. But having said that, if you're an intelligent engineer, you can use that to increase productivity or to get some information quickly, but it's not something you have to rely upon.
Good. Nice, guys. So, all right, by the way, Chetan?
Yeah. When you look at private internet and then private data center versus public, it is still the public are whatever in the Google, Amazon, maybe around 12%, 8 or 12%. Majority of it is in the private enterprise. And what's going to happen is people will get these models, or like Alini was saying, that you will have to have a sanitized version of this in-house. You have to have the expertise that people need to do.
Yeah.
Like this, and people and all of it, and you will need engineers with that.
Exactly. Yeah. See, guys, I'll put the value in 2 words. Besides the learning, see what is happening, guys, and this is my experience. When I came to this country, I was surprised that I was one of the few, actually maybe in my generation, I was one of the few people who happened to know most of the log table and anti-log table by heart. Right? Just through experience, I imbibed it, like using it. And at some point, I just happened to realize that I know the value of most logs and anti-logs. What it meant is I could do most of the calculations by hand. And I had all sorts of mental calculations I could do. There's a Clashenberg system of math and all of that. I came to this country and I realized that at one time I was giving a lecture in physics, and something very simple, 77 divided by 11. And some people some people knew the answer, but I saw half the class was pulling out a calculator. And I still remember my sense of shock and disbelief that it could be done. Later on, when I was in the research area, I was sitting with some really big scientists, actually, without naming them. One of them in the room actually went ahead and won a Nobel Prize. Ultimately, there was this equation on the board, and I was this quiet, humble, graduate student in the background, completely scared of speaking, as quiet as a mouse. And I saw this equation, and they all said, "Oh, we need to write a Fortran routine, or we need to do some scientific calculator to solve it." Right? And from the back, I just blurted out the answer. So they all ignored it. Somebody just wrote it, ignored it. Right? Later on, they came out with the answer, and it was pretty much that. And now, all of a sudden, they're thinking about this quiet genius in the back. I was not a genius. Actually, these people are way, way brighter. But what I had is an ability that had decayed to do mental mathematics. Today, people, they can't do math at all. With the coming of all these technologies, people can't even write. Now, ChatGPT writes all your essays for you. Right? You don't trust yourself. You just put it there and say, "Can you please write it in better English?" And then it writes. I've seen many of you do that. Right? As immigrants, we do that. So what will happen is we will lose the abilities, and you guys, to the extent that these big, see what has happened. You look at it. Before the cloud, all of you knew your machines well. Most of you had good Unix skills. Most of you had good skills at installation and doing things. Coming in of cloud, and they're making it, oh, it's all available as a service, just log in and do it. All of you, your skills are evaporating. Guess what will happen when all of you have forgotten how things are ever installed, right? How things actually work. Do you think the Moore's law will still apply to the cloud economics? They will have no reason to decrease the price. Every time the hardware becomes cheaper to make, they are going to make it, they'll keep the price high, they'll absorb the profit. And the same is happening in the AI industry, right? You don't know AI, you don't know the cost. None of you know what price you should pay for buying a search service, isn't it? And most importantly, the second point I want to make is the reason I chose search as the first project is because search is the biggest antidote to hallucination. What do I mean by that? Don't go to a LLM and ask it a question. Tell it that the question must be grounded or find evidence in these documents that I'm giving you. Right? When you do that, you can't solve hallucination completely, but you decrease the probability of it by orders of magnitude. In fact, that is your next big project, RAG. Right? We will be doing that. So anyway, those are the things. Okay, guys, so that's all I have. Let's take a 5 minutes break. Then we'll discuss what all your projects. So, yeah, I need 5 minutes. Yes.
I have more formal teaching me how to do this. I have a more formal process that go ask you. This is
But you still work on it. I think you can server access. Or on a subscription basis. And then for example, you know, so when you were talking about it, drugs are
It would, but this one, this into the company that we are providing. So only you can make
All right, guys, let's get started. All right, now I'm going to, let me warn you, you might feel a little bit deflated after this, but the good news is, to cheer you up, comfort food is on its way. All right, so guys, this one you have to fess up honestly, each team. How many of you are making your UI in Streamlit? Right? So Streamlit is good. It should be a fallback. Remember, Streamlit is not production. Write it in React or Angular or JSF or whatever it is, but not Streamlit, because a UI has to be served from a site, from an endpoint, from a URL. Right? So, guys, please pay attention here. Yeah, your website, people should be able to go to a URL and see your site and multi-user experience. Streamlit won't give you a scalable multi-user experience. Are we together? So write it in something that is scalable. It doesn't have to be pretty. Remember, we are in product development, and usability is one of the features. It should be usable, not necessarily pretty. If you make it pretty, extra bonus points for you, but Streamlit is not the way.
Can you give me recommendation?
React, Angular, JSF, whatever. Like use whatever framework you like. There are many frameworks. Django, if you want to use Python, and so on and so forth. Python is Django. I don't know how it is pronounced. So not Streamlit, not Grad.io. But while you are doing development, definitely use Streamlit and Grad.io, because you cannot be doing everything in parallel. Right? The backend people cannot be waiting for the UI to get completed. So they should be using either Streamlit or Grad.io. Number one. Are we together, guys? Right. Number two, so just take this down as a basic. How many of your projects have read the doc? You guys have a read the doc?
Read the doc and read.
No. When you go to any open source Python project, you notice that it has a read the doc. It has a website which properly documents their entire product, their library. So to the extent that you're writing backend code and REST endpoints and services, everything should have, or reasonably, not everything, but the essential things should have a read the doc. Are we together? It should, that is in the read the doc should be your architecture diagram, what your trade-offs, what pluses and minuses you use, what are the watchers.
I know we have it as a Google Doc. Like,
Read the doc, read the doc. And the tool
Can this
you
be on
use is
GitHub?
Spinx. Say
Can
that
this
again,
be
please.
on GitHub? Can this be on GitHub as a README?
No, not README, guys. README is not read the doc. Use Spinx. The technology is called Spinx.
Sorry.
HNI.
Oh,
X.
okay.
What is that?
Spinx. Spinx. And guys, just Google up read the doc for anything. Like, for example, for FAST, there must be a read the doc.
So ask if that is that needed for the next weekend?
Yes, I expect to see that, because that goes to completeness. A project is not complete if it is a black box. Are we together? Right.
Yep.
Yes. So it's a see, guys, how many of you are familiar with Java docs and things like that? That is it. Right? Sphinx, right? Sphinx.
Deoxygen also.
Come again?
Deoxygen.
No, it's not. Read the docs is the standard. Are we together, guys? How many of you have used or read the docs? I bet all of you have. If you have been looking at Python libraries, you all have. You just didn't know it.
These are equivalent to Java docs.
Sort of, but in a way, more like a Maven site. What is a Maven site is read the doc. Right?
Most of us, like engineers, like researchers, if we use latex or latex or however it's said. But yeah, so yeah, I'll figure this out. Thank you.
What LaTeX is to researchers, read the doc is to Python programmers and Python software makers. Go ahead, Arun.
Now that you've talked about React and other things, how much attention are you going to pay to style sheets and styling and all of that stuff?
Not much. Usability is more important than prettiness. Okay, guys, next thing, for your core services, you must have, how many of you, which all teams wrote PyTests? Which teams did not use PyTests? Raise your hand, honestly. Okay.
Like unit tests or
Unit tests, yes.
oh.
So write unit tests, guys. See, guys, you don't have to cover your entire project with unit tests. You have just 1 week, but at least your core things like search, right? Index, a few unit tests to make sure. So for each of these basic functionality, parsing, right? Cleaning, chunking, embedding, indexing, searching, at least have 2-3 unit tests, meaningful, right? One class of unit tests at least. Right? So basic unit tests, guys, you must have that. Otherwise, what will happen is I'm telling you what will happen. When I throw my test cases at you, because you haven't seen it, it will take down your system. Right? So you better catch it before. Right? That is it. Now, bonus point, if you can use JMeter or something to scalability test your things, then it's a good point. If you cannot, it's one thing. How many of you actually wrote a test harness to see how well it scales? Very good. Right? So one team, 2 teams.
Yeah, you did that.
Unit
I
testing.
mean, not here in this project, but we have used.
Oh, no. No, it's like, one day.
1 week you are expecting us to write it.
No, it's somewhat like in Hindi, there's a joke. No. In Hindi, there's a joke. There's a saying that my grandfathers used to eat food in pure ghee. You can smell it on my hands. So once in your lifetime, you have written unit test.
As if the original timeline was 6 p.m. last Saturday.
Yes, it was. So guys, here's the deal. You're getting 1 extra week, do it right. The next question is, when you write your microservice, right, how many of you just assume that a single instance, it only works, like you're caching things. For example, you're caching the entire search index in memory. How many of you are loading the fast index into your microservice? I know some of you are. You guys are, right? Yeah, so many of you are. Why is that a bad idea?
Concurrency, right? How do you keep consistency across all of them?
That is right. So what happens is, remember that you're in a producer-consumer environment. Things are coming in, index is being updated. At the same time, you're searching from it. If you load it in memory, what happens? You lose coherence, like you said, etc.
Indexing is an overnight.
But then every night you'll have to restart your
real time. Are you doing real time?
No, I'm not doing real time. But then you want to take your microservice down every midnight.
Yeah, but Asif, actually, to be honest, I mean, we have value in that. Like, when you look at like immutable infrastructure or whatever, we actually restart our service every few hours. So it picks up the last index and we get the results.
Okay. So that is the issue. That's an architectural choice. Satyam is saying that there is value in loading the index into the microservice itself, even though the index might be a few gigs.
Yeah.
Okay. In memory and just looking it up right there itself, computation. Okay. Yeah. What's your question? Yeah.
No, I was saying you want us to include like a Redis class or something?
No, not Redis. So guys, I'll throw you. These are choices. Anybody would tell me what are the trade-offs with this choice?
Bringing a huge footprint in.
Yes. You're bringing a huge footprint in memory. See, what happens, guys, is that in reality, microservices you run on what I call a swarm of bees, right? You use very tiny Docker images, which have very light footprint, so that you can very quickly scale out as the traffic load comes. As the traffic load decreases, you scale down. So generally, it is a good idea for micro. It's just see, by the way, it's not the correct answer. Like Satyam, what you said, that is an architectural choice. But one of the things that I've learned the hard way is that if you can keep your microservice entirely stateless, right? And in a way, holding a big index in memory is not necessarily having state, but you're still holding something that needs to be refreshed. But if you can make it such that any heavy lifting it delegates to somebody else, right? You have a benefit, because that somebody else can be backed by something else that I will now ask you. How many of you, by the way, have cross encoder in the microservice? You do.
At the moment.
So most of you have, right? All of you have. So pretty much I guess that you would do that. And especially if you build the index in memory, you'll have the cross encoder in memory. Cross in this search engine project, explain to me, can somebody identify which is computationally the most expensive item at inference time? When you get it, so imagine a request comes from the user, search request, you're processing it. In the entire lifetime of the processing of the request to a response, which piece is most expensive? Cross encoder. Which piece simply limits your scalability? Cross encoder. You have only so much GPU VRAM and GPU compute power, right? So what should you do when some resource is absolutely critical and will not scale elastically? Remember, microservice scales elastically because it can, like a swarm of bees. But you just encountered something that doesn't scale up like a swarm of bees. So should it be there in the microservice? It should be an inference service of its own. But then how do you prevent? So now I'll ask you this question. How do you prevent a swarm, like a huge, what is called a thundering horde of requests? In architecture, you call it the thundering horde. How do you prevent that?
Throttling. And some sort of eventing mechanism in the backend.
Yes, good. But how do you do that? So,
Queue.
Kafka queue. Satyam.
Yeah, I mean, queues, but what I'm saying is, I think we use microservices as a very loose definition because in the modern scheduling algorithm, you can fix saying you cannot scale this more than 10 inputs.
You could do that. You can do that. See, because that you can set up the Kubernetes parameters and so on and so forth. It is true. But what I'm telling you as an architectural choice, think about this. You have anything that is resource, the expensive resource. Never let a request directly touch it. It's a broad principle. Never let a request directly touch it. Always front end with a queue, because, and this thing is in architecture, we call it event-driven architecture. The first actually landmark paper in this space was something called SEDA, SEDA. It was a wonderful paper, but the code base wasn't that great. But it proliferated a whole slew of thinking about it. And it was a first point of departure from the old thread pool way of thinking. If you remember, one way of throttling the request is by using a thread pool of fixed size, maximum size. You can't have more than that many threads. But then thread pool becomes a single node solution. The multi-node solution can be, like Satyam's idea, you contain the number of container instances that can run, multiplied by the number of threads that each container instance can run, and that maximum is your throttling limit.
That's where the stateless
is sort of, yeah, that's right. So that too is an architectural choice. But here is something I'm telling you guys. There is always this debate between a thread pool architecture and a reactive architecture, event-driven architecture. And reactive is sort of in the same family as event-driven. There's always been a debate between what to do. And here is my experience. If you do anything that is IO or anything that is expensive, always pick an event-driven architecture. Always. Don't go with thread pooling or don't go with any of its variants. Always pick event-driven. But if you do event-driven, hold on guys, let me finish my thing. I know that lots of questions. So what you do is you need to put your inference, expensive inference, in one location or maybe a cluster of these GPU banks or whatever it is, doesn't matter, your inference servers, but have front-end it with a queue. How many of you use some form of queuing? Lots of it. This is really good news. But remember that queuing shouldn't just be used for the producer part, they should be used for the consumer part also. A cross encoder, you should do with, the cross encoder should be protected. Right. So anyway, guys, see, here's the thing. How many people do it? I don't know. Maybe nobody in the industry is doing it. But I'm just giving you, none of these startups or whatever it is are doing it. Or maybe all of them are doing it. Who knows? Right.
We did have a question because we had a long discussion about it. Postgres or a DB or Elasticsearch, this is an active clinical service that you query, you get an answer. Maybe it's our limited experience with files and stuff. What we realize is you create a file index, you store it in a file, a process can load it, kind of thing. Is there an active service that we could use, or have we not looked at the right software to do? See, like I would like to run it as a DB, which has all this vectorized, and we query it. We can find it. That's why we were loading it with an answer.
Yeah, no, that's a very good question that you raised. See, the rule is, so I'll repeat the question for those of you who are remote, because Satyam asked an elemental question, a foundationally important question. He said that, see, Elasticsearch is a service. You can access it over REST and so on and so forth. Databases are a service, they are server. But we are creating an AI index and we are loading it ourselves. Basically, we are carrying the burden. Is that okay or not? So the answers are varied based on how you look at it. If you, for example, if your FAST index is reasonably within size, indices are small. See, even for a thick textbook, the number of pages in the end, which are the index, are quite small. Indices are small. Loading it in memory, like you did, is perfectly okay. The downside is obviously the cache coherency issue if you have continuous updates. But having said that, should it not be a service? The answer to that, so what are the trade-offs? You make it a service. Now there is one more RPC call that you introduce. Now, is that a good thing or a bad thing? See, in architecture, there's something called a single responsibility pattern. Single responsibility pattern will obviously encourage you to, as much as possible, have each responsibility be autonomous. So having your indexing as a service, AI search, semantic search as a service, is a better idea, because that team, that guy can keep swapping FAST to HNSW to something else without the rest of it being impacted. Now, the argument people often make is, hey, I do it with my class design anyway, interface it, adapters, FAST adapter, this adapter, etc. But generally, it doesn't work like that, because there is always a what is called architecture leak, right? People end up getting tightly coupled. But when you make it a completely different microservice, essentially it's a different project. It's a different binary being built. You're much more likely to have it as separation. And so SRP pattern would say that you're better off having your search index as a service, just like your keyword search is a service separately. Yeah.
So, yeah, so not causing that leakage. Let's say we are the team which have built this vector search. Okay? And we've selected, right now we have selected FAS, and we want to give an interface to everybody else to query. Okay? We've selected FAS. I think the question is inside that. Now FAS that we know is a lib. So what does my service look like? Is it a service that loads things in memory? How do I get parallelism? How do I get concurrency?
Yeah, it's a good service. So what I would do is, like, let's literally take 1 second. Let me answer this. What you do is, imagine a microservice that has nothing, just one endpoint. It is semantic search.
Yeah.
All it does is it loads an index, and maybe it does the responsibility of continually loading every few minutes or whatever it is, right? That service gives you a REST endpoint, or better still, gives you a gRPC service. Right? Because gRPC is more, because you are doing within your intranet, within your architecture communication, within the architecture communications are always better off as gRPC. It's efficient. REST is very inefficient. Right? You could do that. And therefore you don't incur the cost, but you have a single responsibility pattern separation. And that search index team can go on its own merry way, keep doing research and making better and better indices. Right? So Anil.
Yeah, so is that like one of the reasons like why Pinecone became popular, because they provided that scalability and database as a service to the index?
Absolutely. Anil's question is that why Pinecone became successful? Because they gave database as a service and so scalability. Yeah, among the many reasons. See, what Pinecone did is, it said you don't need to learn any of this. So you save the cost of this bootcamp. Just register for the Pinecone, right? You get the service. Go ahead.
This might be a very basic question, for other people might already know this, but say we have development, we are jumping in, we are doing some vector embeddings, and we index it. Do we create one index per document, or do we create?
Oh, no. One giant index.
Across all documents.
Yeah, across all documents.
Then with that giant index, the problem is every time I get a new document, I'll have to re-index to update it. So I need to refresh my cache so that I get the latest one.
So very good question. And this goes to the heart of the topic is cache coherency. Mosmi asked this question in the following way. She says, if I load the entire index, then every time I add one more document, I can't search for that in the index. It is true, right? And that is why, I mean, now you're dealing with real life issues. How do you concurrently update and be able to search for it the next second? And the answer to that is not that hard, but I would rather that you discovered it on your own.
One in one case, smaller size index per document, and then you search per index that way you already.
No, you'll have you simply will not have enough file. Imagine. So let's take Mosmi's suggestion is why not have one index per file per document. See, what happens is the realities of the operating system will kick in. Unix, for example, gives you only a finite number of file handles. You will literally run out of file handles. You don't have a billion file handles. Right?
Why can't we partition into different index files? Like, let's say I have 10,000 or 100,000 rows of chunks. Right? And
Then you'll have to search each of these. Then you'll have to do scatter gather. Mani's question is, why can't I have, let's say, 50 indices? Right? The trouble with 50 indices is your query has to do scatter gather. Right? It has to scatter across 50 indices, search all of them, and come back and gather the results of 50 indices. So guys, these are great questions you're thinking. This is the architectural thinking you need to develop. Is it a good idea? In some situations, possibly. In some situations, not. Should you maintain one index per department? 1 second, right? For example, finance will have an index so that the rest of the company doesn't see the search results, right? Right? You don't need to know how many extra zeros the CEO and the C circle has in their compensation, right? So do that. Go ahead. So I just Shivani was ahead of you.
So I was just going to say, this is a black box to us because again, it's behind Azure and Amazon and all that. But the way we've done this is that we also are allowing through the UI users to upload additional documents.
Right.
And then I'm able to search
Yes.
against it.
Yes.
You see, so on the fly, that's happening somehow at the back end.
Absolutely. Absolutely. And what I'm trying to tell you is concurrent update and seeing the result is not hard. In fact, that's one of the test cases you'll face, right? So at this moment, I gave you a soft benchmark, which is that imagine that you are doing update of your index once per night, but a bonus, a stretch goal is if you can do it in near real time. It won't be real time, but near real time, right? Or with low latency if you can do update. Anyway.
So how fancy can we go with this? Like sharding and time-based partitioning, these things are all on the table, right? So we only have limited time for the project. So
you have one whole week. So 6 people, 24 hours, 7 days, seven days.
Even to improve on the indexing and trying to do
instead
of a global index.
No, guys. See, here's the thing. Think of it as a race. Completeness. So there's a point of diminishing returns, right? AI model metrics, it should be good. Your results should be good. Scalable, performing, high performance. These are your metrics. So go only that far. Okay, so this is an important topic, guys. I hope you got it. The lesson, Srinath, hold on. The lesson that I'm trying to make is, ever you have an expensive resource, guard it, right? You guard it in real life. You know, your mom makes sweets and all the kids are trying to enter the kitchen. What do? You guard it, right? And you ration it out. So it's the same thing. Srinath.
First comment is that I just hope that as let's say the interfaces, whether it's EF or REST, if that was the first project, so that we can make the code component and then build an application around it. So that's one comment that I have. The second part is regarding the closed encoder. Like you mentioned that closed encoder shouldn't be part of the microservice or the server. Right?
No, you can, but it's an architectural choice.
So I just wondering, if I move this closed encoder out of the microservice, what does the microservice do? Because it's essentially just like a shell without any much business logic. So
it is the one. It is the dispatcher. It's the router. It is the one that gets the request from the user. So good question that he asked is, what does the microservice do? It is the one that's orchestrating. Given a query, it goes to Elasticsearch, gets top K results. Let's say top 10 results. It goes calls the fast service and gets top 10 results. It pushes it out to re-ranker service and gets the re-rank results. And you do it. See, guys, I'll tell you a reality. Here is what I heard. And those of you who know better, correct me. Google, in processing each of your queries, dozens of microservices participate. Think about it sometimes, right? It is a collaborative result, and yet it answers the questions in milliseconds, right? You can do that, Albert.
It's like a transaction. Let's say, suppose one of them fails. So I go to Elasticsearch, my Elasticsearch goes down. And then I'm doing the other one, so then that whole thing will die, right? So that part has to be handled.
That is true. So one question that Albert raises is, What is a failure tolerance? What if your index, see, one thing that will happen, guys, is as you do this, which thing is most likely to fail? Cross encoder will have out of memory errors. What is, and it is not something that you can have high availability of, because you guys have one machine, right? So what do? What is your fallback strategy? The fallback strategy is just mix the results that you got from the two indices and send it forward, isn't it? At least you are producing results. What if your
results is better than?
Yeah, exactly. If elastic service goes down, just the semantic search results are there, right? If both go down, then we have to worry.
To somebody's else machine.
What is
Satya's machine.
Yeah, know each other's IP addresses. That is right. Okay, so guys, finally, I will. Okay, guys. So one last architectural question: how many of you are storing? How many of you are storing the index files in the database? PG. Yeah. PG vector. No, you're storing the vectors, not the index.
Not the index.
You're storing the index file itself.
Index is on the
But we are
file
not using the PG vector. We still use file.
Why are you storing it in the database?
We are also storing the index, the
Embeddings you store in the database is fine, but why? Like, I want to bring it up for debate. What are the pros and cons? What exactly do you gain by storing a giant binary file in the database?
I mean, you can back it up and backups and restores.
We don't want to be on the.
If you're using a ZFS, if you're using or any kind of replicated file
If you're
system,
using NFS, yeah.
yeah. How does it matter?
You can encrypt it. I don't think so.
Encryption you can do on file. See, guys, all that databases do, when they get a big binary block, all they do is they create a file of it, out of it. Right? You don't get anything more generally, and you get an entry that there is a file. Yeah. So guys, here's the thing. You degrade actually the performance of databases by putting big binary objects there. Don't do that. As a person coming from Oracle, the first thing I'll tell you is avoid putting big binary objects in databases. Databases were not designed, relational databases in particular, were not designed for that. Yes, they were not designed for that.
Why would you save it? You have to save it in files.
In any file system. So yeah, Mosfet's question. So the alternative is file system. What should be the properties of the file system that stores that?
Shared.
Why should it shared?
No.
Yeah,
NFS,
all the
NFS
nodes-
Replicated.
Yeah,
You mean
replicated.
replicated? Some form of replication should be there. Durability. You need to guarantee durability of that. Right?
So sharding of the index file.
You can't shard the index file. You'll be in trouble. You'll have to do scatter gather. Remember? Go ahead, Masan.
Okay, I can take it offline if this is from your topic. I'll just leave the question for people to ponder. If I am in from cloud service, multi-region, multi-AZ, how do I make it work?
See, the moment you do multi-region cloud, you need to do one of two things. Let's take Google, for example, GCP. If you store it in the object store and you create a project as multi-region, they are under the covers doing the replication. Right? Yeah. Now, remember, guys, that whenever you do a replicated file system, it becomes a distributed system. Distributed systems, you have to be aware that there is a theorem that looks like a cap. What does it say?
Paxos.
Say that again.
Paxos means where all the replication is successful or not.
No. Not that. See, there is a theorem called the cap theorem. Has anybody heard of it?
Yeah. Right.
So what it means is basically it's a trade-off. The fact that the moment you have a distributed system, you are in a world where partitioning can happen. In the presence of partitioning, simple thing, partitioning happens, there are two copies, right? Because you're in a distributed multi-region system or something, there are two copies. The services can reach one of the copies. Based on which service you reach, you can either give an answer or not give an answer. If you give an answer from one of the copies, what's the risk?
Out of sync.
The other copy may be out of sync, isn't it? So you lose consistency. So that becomes a trade-off of high, like, a high availability, low consistency, eventual consistency, actually, eventually. On the other hand, if you say, no, I'll stop the train. If I can't, if the network, the moment there is network latency, by the way, real partitioning never happens. What happens is latencies become big that effectively act as partition, right? So when you have that, then to avoid cache coherency, you can take down availability. Are we together? Right. So when you write, you need to durably write to all the copies. Go ahead.
Will you use Cassandra or HBase for storage like this?
No, Cassandra, HBase, so they serve different purposes. But if you look at HDFS, it gives you that service, right? It's a distributed thing, ZFS and so on and so forth. There are different levels at which you can do replicated file
the region.
Yeah,
and here just use S3 or something.
Yeah. So all of them use basically a distributed protocol to put bits and bytes across. But see, anyway, guys, what I'm doing is just evoking the architectural aspects involved here, right? That is it. And with that, I'm going to end. Anil?
Yeah, so if we use Spanner, like, will that address this issue?
Very good question. Spanner, he says, will Spanner address this question? Never store your binaries in a database. So Spanner is a distributed transactional database. It's a global database. It's a global distributed. It's a globally distributed transactions it can do. It is not the use case for this. It is not the use case. Spanner is not a good use case. I mean, this situation is not a good use case for Spanner.
Small.
Kazik.
Do you need to have like an architecture diagram as part of the solution?
Or read the doc. We should contain that.
So we should put it in there.
We should put it in. Right. So guys, when you think through it, now you realize all of you need a message queue. All of you need to protect your expensive resources behind a message queue. That is the one lesson I wanted you guys to learn. In this, my main goal of this project was that all the other pieces you'll get right. You'll get practice in. Right? But I wanted you to learn one big lesson. GPUs are terribly expensive resources. Terribly expensive. Always hide. It's like mom hides the sweets in a cupboard. In the same way, hide your, what's that? Any queue you want. You can use RabbitMQ, Kafka, or whatever you want, right? Yeah, and ActiveMQ, Artemis, whatever it is. Kafka by default, see, in the big data world or a data at scale, Kafka is by far the most prevalent.
Kafka streams actually is the most best throughput.
Is very high throughput, yeah. All of this, so use that. And by the way, guys, the Python library, the Confluent Kafka library, gives you an excellent feature. It gives you the feature that you can put a message and wait for it to get processed by the consumer, and then get the result back. Because what you do is you put, so guys, how would you do it with Kafka or with any of these? Put your messages, the requests that come, into one topic. Have the consumer consume it, produce results, and put it in the second topic. Consume from the second topic, just know the ID, the correlation ID.
Also, one thing I learned from this project is divide your task, bigger task into smaller chunk and distribute it as a jobs, small jobs.
Absolutely.
So that everything runs together and everything works. Otherwise, one job will fail often because of the memory.
Of course, Prakash. Divide and conquer, the old British style, right? Apparently, when India got free, there were more than 500 Maharajas. So they really played divide and conquer. So should you?
So you use some sort of a DAGs or airflows.
Yeah. Oh, yeah. So yeah, by the way, jokes apart, and I don't know if it was a good joke, but I hope no Brit is offended. So see, here's the thing. The moment you divide, you introduce complexity, because any one of the individual pieces can fail. And so you inevitably have a directed acyclic graph. Yeah? Any pipeline, any workflow is a DAG. And now you have to maintain the DAG. I would suggest those of you who haven't played with pipelines, etc., just use Jenkins. Jenkins is the easiest one, right, to do. Airflow is the next. Airflow is another great one. But see, sorry, one second. Airflow, I hear, that it's losing steam, and there are other ones that are coming up.
Argo is writing up.
Argo
bunch
CD.
of- yeah, there's a bunch of-
But Argo CD, I thought was just for CI/CD. No, not for regular AI pipelines. Use ML, the ML ops, the ML flow, ML
Ray
flow and
or
many
ML
things.
ops.
Ray, ML flow, yeah, things like that. Cube flow.
Yeah.
Anyone of you dares to use, I mean, go the full blown Kubernetes, then go with Cube flow. One second, a few questions. Mosmi, go ahead, and then you.
I was just following up on what you said. Sorry, I did not capture that.
Yeah.
Pipelines, right? It's not something about Jenkins, but. what
Jenkins is the easiest one for you guys to do this project
But
with.
this is CI/CD, this is not CI/CD.
No, Jenkins can do anything. It's a general purpose pipeline. Prakash?
Yeah, so do we have a Kubernetes cluster?
Build one. It is called a mini cube. You got a server?
Minikube, but it does not offer like ingress and load balance.
No, we don't have.
So that's why.
Yeah, but what you can do is collaborate with the other teams and make it into a full cluster. But that's up to you.
Okay.
Like, Saurabh. No. At this moment, I would suggest that go with something more AI specific. Either go with something simple as Jenkins or go with something that is AI specific like ML flow, Ray, Kubeflow, etc.
So if you go with that, we have to maintain some state with the workers die and all of that.
All of these will do. Even Jenkins will do.
Out of the box.
Jenkins gives you very good DAX. Reasonably good. I mean, simple enough DAX. Yeah. All right, guys. Any other questions? So now, guys, I want you to, how many of you have filled that survey on the first project? If you have not filled the survey on the website, your first impressions of the project, now is the time. You can tell me if the project is easy or hard.
So you have another survey, right? Or
Yeah.
another
No.
quiz, sorry, second quiz.
Yeah. By the way, I've also released a second quiz. It's on, what was it on? Activation functions. Okay. But take this quiz. Okay, guys, I want a hands off just because I know that you guys are lazy, you won't do it, or you should do it. How many of you are finding this project bigger than you thought? So, no. So here's the thing, guys. This is the nature. I'll tell you something about engineering that it's an old wisdom amongst architects, and you'll find it in books. And my previous boss used to quote it quite often, and I used to agree with him. Engineering projects are always way bigger than you think. Always way bigger than you think in the beginning. They take longer than you think, but here's the positive side. They impact, their real life impact, if you succeed at them, always exceeds your imagination. Right? You succeed at an engineering project, its impact is way bigger than you think. Look at the Golden Gate, right? We live in the city. I mean, we are identified as the Golden Gate city, right? The San Francisco Bay Area. Nobody imagined what tremendous, I mean, people knew, but I don't think they fully understood the scale of the impact. And so you guys build this. What's the next stage? All your projects will build upon this project. All of them. Yeah.
What will the test do? What's my input in the pipeline?
I'll give you two inputs. For the pipeline, I'll give you a directory of documents, which I've maliciously engineered to take your documents. So in other words, it has some very long documents. It has extraordinarily large number of short documents.
So you just point us to a directory, local directory, and that's what we do.
Yeah.
What was the second one?
The second test is of your search.
Oh, no, that's fine. Okay.
That is
The input is just you point us to a directory.
I'll point it to a directory. Okay, guys. Now let me also say things that you may not have considered. I don't know if please like look at me. So, guys, please pay attention for a few more minutes. Guys, just pay attention to me, guys, please. A few minutes. Almost done. So, two more things. How many of you are reading documents in many formats? All formats. Right? So, when you read documents in all formats, how many of you are using the best library for that form? If you, which one are you using? Srinath? Yeah, if you're all using Tika, you're using a jack of all trades, master of none. Use the most dominant formats are PDFs, etc. Use the best parser and HTML, etc. When you know that something is dominant, you pay special attention to it. So make sure that your parser has special handling for the dominant formats, because Tika is not the best. Now, I suggested Tika, of course. It's my job to give you at least a solution. Yeah, of course. No, you don't have to adhere to my spec. See, guys, the specs that I give you is a lowest common denominator, right? It will get you to a solution. But if you have time, especially now that you have time, guys, I'll take questions in the end. I want to come to another topic. So you have time, do it right. Number two. Okay? The second thing is, how many of you have handling for multilingual? Any team that did multilingual, because your test cases will have Hebrew, Thai, Chinese. So Tika has support for 18 languages. The test case that I'll give you is within those 18 languages. But parsing is not where you'll fail. Think your pipeline. At what stage you'll fail. Where do you need to be language aware besides parsing? What else?
Vectorizing the embedding.
Vector embedding, cross encoder. You need to use, and how many of you actually had the foresight to use a multilingual embedder? We don't. Okay, good, but actually one person did.
But again, it goes back to like using the best for that job. So if I want Hebrew, I will do a Hebrew.
You could do that also. So guys, here's the thing. You can use a multi-purpose. Actually, see, here's the thing. If you do it only for English, and I saw all of you, I mean, you didn't even notice that the models you were loading literally started the word with EN. Right? So what does the word EN tell you? It's only for English. Right? And that again speaks to, we live in a multicultural world. So you have to, now, first thing is don't make that mistake. Second, you can use a multilingual encoder to do many languages. Better still, you can use a specific encoder for each language. But then what happens is you will have to do scatter gather, because you'll have to maintain multiple indices. Each encoder will produce a different embedding, right? And you'll have to maintain different encoders and do scatter gather. So you realize, guys, that taking something to production, genuine production, full scale, has a lot of interesting things that you can do. And as you do it, as you do those things, that is how companies are built. See, great companies are built not based on some absolutely genius idea. Great companies are always built. You know, it's called moat. When you make a business, you need a moat so that people can't catch up with you. Most of the moat of companies comes from the working hard at very simple things in the wee hours of the night. Right? It is the little things, little beads you put together and you make a garland out of it. That gives you your moat. Each of these little ideas, you can keep on improving. And at the end of it, would you not say that if nothing else, you are better than the 3 lines, for example, I'm told that Henry Pace or on the web, there's 3 lines that will do a search. Oh, it's a line chain. We'll give you 3 lines and do a search on a DOM. At least that will not compete with you. Right? So that has its purpose, but you're building a product. Right? So please get into the mindset, genuinely get into the mindset, guys, that you are a startup. You're working day in and day out and building a real product, a new product. Forget about the fact that we are a few years too late. Pinecone exists, eBay exists, and these guys exist. Imagine that you're doing it like that. Be in that spirit, and then you'll have fun with them. And then, guys, now that I've told you all the things you missed, it's time for food. Yeah. You shouldn't use them. You shouldn't use.
not about, we can use either.
Now,
How you protect your over there, I have tools, I can just deploy. I have all these. But you all have to service. Memory load. You wanted my address. That's then I think about have a long, have a